probability has the following axioms. These are the properties of probability that we need to know.
Okay.
The condition probability A given B is simply given by A intersection B over B. The B goes down there. B given A is given by the A goes down there and intersects A intersection B. This same formula can be simplified as follows. A given B times B will give you A intersection B. B given A times A will give you A intersection B. A intersection B can also be multiplying the probability of A and B directly. This one is only used when you don't have what? The conditions. When you're given A and B only, you're simply going to just multiply them.
Okay.
But if you're given A given B, you just multiply A given B times the base.
Okay.
Then the union set is A union B is equal to probability of A plus probability of B minus A intersection B.
B.
So the rules are as follows. If you have A given B and you get it to A, you say they're independent. B given A times it should be equal to B if they're independent. For mutual exclusiveness, A intersection B is equal to 0. Okay. Now, with the aforementioned, we're now going to look at our exam question paper. So what's the probability of A? 0.6, 0.5, B 0.6, and B given A is 0.4. So our A is what?
0.5.
0.5. Our B?
0.6.
0.6. And
probability A given B
is what? 0.4. So can somebody tell me, since we have this condition probability, what do I multiply this one by to get the intersection? Is it by B or by A?
by B. By A, sorry.
It's by the base B. If you're not sure, you simply start by expanding A given B. And our B will be down there.
Yes.
And here we have A intersection B. So A given B is 0.4.
0.4.
Intersection is what we're looking for. And our probability of what? B,
which is 0.6.
0.6. 6.
First multiply. So meaning our A intersection B. What? 0.4 times 0.6, which is
0.24.
0.24. Are we clear this far?
Yes.
Now try to find A and B. Find A and B.
Probability A plus probability B minus intersection A and B.
Intersection of A and B. So calculate that.
Yes.
So now how do we find so our A given B was what? How do we know that two sets are independent? A given B must go to A. Zero 0.5, 0.4 is our A given B, and our A is 0.5. So this is 0.4. A given B is 0.4 and A is 0.5.
0.5.
Are they the same?
No.
No.
So we say not independent.
Mm.
To know whether they're mutually exclusive, we compare them now. Our A intersection B must be
Equal to 0.
0. So what was our A intersection B?
It was 0.24.
0.24. Then the same, right? So we say not what? Mutually exclusive.
Not mutually exclusive.
Because it's the same. That's a condition. Is that clear?
Yes.
Okay. So now we got to our topic called hypothesis testing. So to start with, hypothesis testing, yesterday we learned a song. We have 99%,
99, 98,
98,
95, and 90.
and 90. The significance level is the difference of 100. 1,
1,
2,
2,
5, 10. So now alpha, 0.01,
0.01, 0.02,
0.1.
0.05,
It's simply
0.1.
when you divide this one by 100, you're just dividing this by 100. Z alpha over 2.
It is 258,
158.
233,
Mm-mm.
196, and the last one, 164. Okay.
Okay. So a hypothesis to start with is simply an assumption which is subject to statistical proof. An assumption to statistical proof. So
Assumption.
if you are testing a hypothesis, you want to test what assumptions people have put in. If say newly-born baby weighs 3 kgs, that's an assumption. So the formulas we need to know are Z is equal to X minus mu over standard deviation and square root of N. So we only use this when our N is greater than what? 30.
What's N?
N is the sample size.
Okay.
So there are the following steps that are required. Number one is state the hypothesis. Number two is state the decision, the level of significance. Number three, you set the decision rule. Number four, you get the Z statistic, the test statistic. Number five, make the decision and the conclusion. So we can start with the basic one here. We are given now a hypothesis and alternative hypothesis. The mu is equal to what? 10. Mu here is not equal to 10. And our x bar is 15. Our n is 36. And our standard deviation is 4. Our alpha is 0.05. Start step one, state the hypothesis. We've already been given our hypothesis. Mu is our now hypothesis, our original thought. So mu is equal to 10. Mu is not equal to 10. Step 2, the level of significance. At 0.05 means our level of significance is 5%. So SL is 5%. So meaning our Z at this point is what? 1.96. So our decision rule, we're going to reject our HO if it is what? Less than negative 1.96, greater than
or greater than negative of 1.16.
So we say reject if HO is greater than, if HO, reject HO if Z calculated is greater than 1.96. Test statistic, our formula for Z is what? X bar minus mu standard deviation over square root of n. So our X bar is 15. Our mu is 10. Our standard deviation is 12. Our sample size n is 36.
It's 36.
This is 5, 36. And this is what? 2. We get 2.5. So we identify where the 2.5 is somewhere here.
Yeah.
So 2.5 is here. So this is called the accept region. Whenever we're going to accept a hypothesis, it means there's no difference between the two means. This is called the rejection region. So whenever we get here, we say reject HO. Reject HO. So this is how we are supposed to answer a hypothesis testing question. Sometimes it will come in a word problem like this. Farmer who has used a specific fertilizer for many years knows that his average yield is 2.5 tons per hectare. This is the historical mean. It has no sample size attached to it. It's called our mu. The standard deviation, 0.53. So our sigma standard deviation is 0.53. The fertilizer is discontinued and he has to use a new brand. He suspects the new fertilizer might alter the yield, but has no idea if it will be an increase or a decrease. So this is a two-tailed test. You're going to use equal to or not equal to. If they say it will be an increase, you use greater. Decrease, you use less. But here it's saying he has no idea, so this is a two-tailed test. At the end of the season, he finds that his yield is 35 in 35 plots. So our sample size n is 35. The average yield is what? 2.65. So this is our X bar. X bar is calculated from the sample size. So we now have all our data. Our mu is simply an assumption. If I say it is believed that a newly born baby weighs 3 kgs, that is your mu. It's your own theory. But after sampling 100 babies, they actually weighed 4 kgs. So the 4 kg is X bar because that's the sample size attached to it. It came from 100 babies. So this is our mu. Our N is 35. bar is 2.65. Our level of significance is 5%. In our Z is what? 1.96. The standard deviation is here. So if I follow the steps, step 1, set the hypothesis. Mu is equal to what? The mu is given 2.5. So say 2.5. And here say mu is not equal to what?
Not equal to 2.5.
5. Step 2, set the level of significance. The level of significance is 5%, right? Meaning our Z is what? 1.96.
1.96.
So far, are we together?
Yes.
Mumbi, are we together?
Yes.
Step 3 is set the decision rule using a two-tailed. If it was one-tailed greater, I would have just said it. If it was less, I would have just said it to the left. On the left side, our Z is always the negative. If it was greater only, if you knew that it would be an increase, the one shaded on the right side is the positive. So decision rule, we can say we reject what? H4 when if Z calculated is greater than 1.96. That's the two-tailed, or it's less than what? Negative 1.96. Then the next stage is you get the Z. Z is equal to X minus what? Mu over what?
Mu.
Standard deviation.
Standard deviation square root of n.
Our X bar was 2.65. Our mu was 2.5.
2.5.
Our standard deviation was 0.5 what? 0.53.
0.53.
And our N was 5.35.
32.
What do you get? What are you getting?
We have negative
1 point.
Oh, sorry. Zero point 0.18.
The final answer is 0 point.
Oh, divide by, okay. 1.67 divided by 18.64.
That's the final answer.
That's what I'm getting, minus 2.5.
We do it in phases.
Mm-hmm.
Oh.
2.65 minus 2.5, what are you getting?
0.15.
0.15.
0.15, okay?
Mm-hmm.
Then below, then below is
I'm getting
0.53 over square root of the 5. What are you getting?
0.089.
Are you sure?
0.08. If we round it off, it will be 90.
Then when you divide this in there, what are you getting?
1.67.
1.67, yes.
So 1.67 somewhere here, inside here. So So what becomes the conclusion?
We accept.
Yes, we accept H4 and conclude that what? There is no difference. Whenever we accept, there is no difference, no significant difference. Whenever we reject, there is a significant difference. So
Okay.
this fertilizer is useless because there's no difference. It only becomes something is happening when there's a difference. So if we go to our exam to look for a question on hypothesis testing, okay, I can't see any hypothesis testing on chi-square and something else. Okay. Otherwise, hypothesis testing is very easy. This is what you're supposed to do. We can try to also understand what we call a two-tailed test. A two-tailed test is what we're just from doing. Let's go through together. 99, 98, 95, and 90. What is our Z for a two-tailed test?
Z.
Here is 2.58. And here?
2.33.
2.33. And here?
1.96.
And here?
1.625.
So fine. But if it's a single-tailed test, here it's 2.33. Here it's 2.05. Here it's 1.645. Here it's 1.28. Here the signs are equal to or not equal to. Here it's greater or less than. So suppose we have a hypothesis which is like this here. Mu is 10 and mu is greater than 10. Our x here is what? 18. And here is 49. Our deviation is 14. And the alpha is 0.02. 0.05. Okay, so step one, set the hypothesis. Hypothesis is already here. Step two,
The level of significance.
our level of significance, which is what? 5%, right?
5%.
Then our Z is what? Since it's a single tailed because of the sign, we're not going to pick 1.96. We're going to pick what? 1.645. 1.645. Step three, this part here. We have 1.645 on the right
1.645.
side because the sign is greater. If it was this and I'll use the other term. In step three, step four, we calculate our Z. Z calculated is x
X bar minus mu over standard deviation square root of n.
X bar in this case is what? 18 minus what? 10 over 14 root what? 49. So this is 8, and this is 2. We're getting a 4 here. The 4 is somewhere in here. So do we accept or reject? Yes.
Reject.
Since our z calculated, which is 4, is greater than 1.645. We reject H1 and conclude that there is a significant difference. That there's a significant difference. So whenever there is a rejection, there's a significant difference that is happening.
Okay.
Together?
Yes.
Yes.
So this is one of the most interesting topics, but people don't understand the basics because they feel.
Sir, I've got a question. Hello?
Yes. Can I?
Is it always that the level of significance is 5%?
No, it's not always.
Okay.
If you're given 2%, but if you're not given a level of significance,
Okay.
the standard one is what? 5%.
The 5.
Yes.
Okay. All right.
Yeah. All right. So the question is, how do I know that it's a single-tailed or a double-tailed? Let's look at this question here. The weekly wage of a semi-skilled workers in an industry is assumed to have a population mean of 286.5 and standard deviation 29. If a company in this industry pays a sample of 40 workers an average of 271 a week, can they be accused of paying inferior wages? To start with, which one is our X bar? Which one is our mu? Which one is our sample size? And which one is our standard deviation? What is our X bar?
Our X bar is 271.78.
271.78. Why?
It's from a sample of 40.
Because there's a sample good of 40 and 40. Excellent. And what is our mu?
Our mu is 286.50.
286.50. And our standard deviation?
29.47.
29.47. Good. Then our word inferior means what? Less than. So
less than.
it's a single tailed. If it was silent, if you just say test the difference, that is the double tailed, it's unbiased. But this one already, you can tell that this is less than. That's why I'm putting less than here.
Okay.
So since you're not given level of significance, the standard is 5%. You're not given. What is our Z at 5%? 1.645. So step 1, state the hypothesis. Step 2, level of significance.
Level of significance.
5%, which has a Z of 1.46. Step 3, calculate the Z, which is give you negative 3.16. Then you compare. So at 5%, our Z is 1.64. So you're going to check in here, negative
1.6 1.645.
Then our critical value found somewhere here, negative what? Negative 3.16. So it's in the rejection region.
Yes.
So it means we're going to reject HO, meaning by rejecting HO, we're accepting the null hypothesis to say these guys are paying inferior wages. So whenever
Okay.
rejecting, we can conclude that what? There's a significant difference in the wages. So we can simply agree to say that they are paying inferior wages. Okay, so I will give you some work to do based on that. So this is where we end our tutorial. Is there any questions?
Okay.
Thank you so
So
much.
you send the questions for us?
Yes, I'll send you questions.
Okay. Okay, thanks.